Hey, welcome everyone, folks. So, I hope you can hear me well. We're continuing our LeetCode marathon for now, and today we are going to change it a bit. So, first of all, as I promised in the Telegram channel that you should all subscribe to, we're going to solve first of all the problem that was given to one of my friends that was interviewing in one of the big tech companies. Of course, I cannot say name, either friend or company, but you should know that, yeah, this question was pretty much recently asked in one of the big tech companies, so we can be pretty close to interview experience, and we're gonna solve it, or at least try to solve it. I didn't solve it before, so I don't know what we are waiting for. Hey everyone. Yeah, I might be a bit stressed right now because I'm overwhelmed with my work, and probably after stream I'm gonna continue working for X hours still, which is okay, but still, yeah, just a little bit of stress. So also we're gonna keep our stream not that long. Once we're done with that problem, we are going to move to, yeah, this is how I not pay for LeetCode Premium, is that I'm asking my friend to just give me a screenshot of premium problems, and then I'm gonna just solve them one by one, essentially. Yeah, but never pay LeetCode Premium, no. So yeah, that will be it. So let's take a look for the problem initially. So this is that problem. Actually, we would be able even to solve it using the current editor in some sense. So let's try to understand it and like what is going on. Hopefully you can hear me well. I really hope so, and you can see everything well as well. So yeah, let's try to understand the problem. So we have m people numbered from 0 to n minus 1, and a single door can only be used by one person at a time. Each person takes exactly 1 second to pass through the door. Okay. So let me kinda amazing draw it in some sense, right? It will help us a lot. So what we have here is, yeah, you should be able to see. Hey, welcome everyone. Yeah, hello everyone that just joined. We're solving problem at the moment. Hit blurry cam. Oh, I'm sorry. Is it better? I don't know. But cam, who actually cares about my face? I can remove it, but I just need this thing for YouTube. So it promotes better the video. I guess it kind of makes sense. Otherwise, I would remove my picture completely. Anyway, so we have people from 0 to n. We have only single door. N people, one person at a time can cross it. Okay. Each person takes exactly 1 second to pass through the door. Okay. Again, array. So arrival, the time in seconds when person I arrives at the door. Okay, so there are people who can arrive. So this is enter, let's say. So there are people who are waiting to arrive, and state where person I wants to enter or exit. So there are kind of two queues of the people essentially. All of them are waiting to go through this door. All right. When multiple people want to use the door at the same time, they must follow these priority rules. If the door was not used in the previous second, people who want to exit go first. So if the door was not used in the previous second, people who want to exit go first. All right. When multiple people want to use the door at the same time, they must follow the. If the door was not used in the previous second, so how come these are multiple people? Okay, someone entered in the previous second. People who want to enter go first. Kind of makes sense. So if I see there are two persons here and one already entered and went here, right? These two guys are still waiting and second one just goes behind him, kind of inertially, whatever. Kind of makes sense, close to reality. If someone exited in the previous second, people who want to exit go first. Same way, but the opposite direction. Okay. So if like entering has started, we can then make sure all the people that are going to enter go, if they are piled up in the queue. Same happens to exit. I still didn't understand the first rule. Among people going in the same direction, the person with the smallest index goes first. Among people going in the same direction, the person with smallest... Okay. So it means like this guy goes earlier than, let's say, this guy. And same applies here. Okay. I just don't understand this case. The task is to determine the exact time in seconds when each person passes through the door. Return an array answer where answer I is the time when person I crosses the door. The exact time in seconds when each person passes through the door. Okay, so we're gonna have some global timer probably. Okay, this is the example. Let me draw the example. So we have T1, person 0 wants to enter. So I will draw people as numbers. Yeah, very exactly in this situation. So we have person 0 wants to enter, T equals 0 still. Enters at the time 0. Okay, so as a response, person... Okay, so we enter T, which is current T. Okay, 0. All right. Then we have next second, which is T equals 1. We got two ones here. Dobro večer, kozače. Привіт. So we have two people coming at the same time, right? Which is good. And for now, oh my God, I'm so stressed about the work. You cannot even imagine. I'm now thinking, what should I do right after the stream? This is crazy. I need to zone out for next hour. I'm sorry. So now I have two persons trying to go through the same door. So the situation right now, so this guy kind of disappeared. Now we have two people. One wants to enter, second one wants to exit. But the thing is that previous person, let's, this is supposed to be different index. So we have person 1 trying to exit, and person 2, which is this guy, trying to enter again. But since we know that person 0 has just entered, we should use the rule that previous, how do you revise LeetCode, how do you retain information? Well, I keep this doc for myself, revising every single pattern I need before interview, and I'm doing daily LeetCode, which is not the best way, to be honest. So I don't know, you should be doing probably a couple of questions every weekend. That's what I would do. All right, so wants to exit and person 2 wants to enter. Since someone entered at T0, person 2 entering has priority. Okay, person 2 enters at time 1. Okay, so there is person 2. What? Why this is 3? Ah, yeah, this is person 2. Oh, I'm sorry. So person 2 I will need to rewrite it. So this is 0, 1, 2, 3, 4, whatever. Person 2 enters at t equals 0. Oh, sorry, 1. All right, so this guy kinda also entered. Person 2. Amazing. Now what is happening? We are moving to the next second and we have person 0, 1, 2, 3 coming at second 2. So second 2 right now. And you have person 3 wants to enter as well. And since previous one entered, yeah, it should go first. Priority, person 3 enters the time. Okay, makes according to this rule. If someone entered the previous second, people who want to enter go first. Makes sense. So this guy is going to be blue as well. And person 3 entered at 2. Right? Right. Now at time 3, okay, now we have time 3. Where's my time 3? Only person 1 wants to exit. Person 1 exits at a time 3. And I think this one is a bit confusing for me, personally, because these are the rules. And if the door was not used in the previous second, so people who want to exit are exiting only when somebody has already exited or when no one used the door completely. I a bit don't understand this, to be honest. Because it was used previous second, come on. No? Or this is only when we have like pile of people. So if we have only single person, we kinda don't care. I don't know. I don't really know. So let's see. At t equals 4, only person 4 wants to exit. Person 4 exits at time 4. Good. So let's say time equals 3 and then person 1 eventually exits because there is no more, how to say, competition for the door, whatever it sounds. And then at t4, t equals 4, only person 4 wants to exit again, and it just exits. Because previous one, or maybe, okay, good. Okay, good. Sorry folks, I need to go for 1 minute, or maybe 3-4 minutes, so bear with me, and yeah, let me maybe put a note somewhere here. We'll be back in 5. Yeah, I'll be back in 5. I'm back. So, have you got any idea about how to solve this? Problem? Again, I'm reminding this is the legit problem that was asked on the real big tech company. So for me, since we might have multiple people that want to use the door, okay. Yeah, let me use my Visual Studio Code. And then, yeah, we are going to use the following one. Okay. Write your brilliant code here. Yeah. Brilliant code. Exactly. Brilliant code. So, hey, hello. Yes. Oh, sorry. Anyway. So it seems like m people number single door can only be used on person time. Which person exactly is second pass through the door? Okay. Okay, so multiple people want to use the door at the same time. So we have base case, essentially, which says us, in case we have single person, either on entering or on exit, we just trivially let it go and pass as a second, right? So it's not a problem. Yeah, also this is the problem, like how to keep track of this t. We should shift. We cannot just have a while loop and increase in t every single cycle, thus kind of emulating the time. We probably cannot do that. Oh, sorry, intuition, we shouldn't look even. Let's try to solve on our own. Sorry, I didn't see the intuition. So how we can do that? What can be our intuition? So maybe we for sure can have some global variable for, maybe I can do this, I don't know. We for sure can do some global variable for time, as we discussed. Maybe I can already think aloud in the code. Hello, just wondering what makes Python feel simpler than JS for you? It's a good question. I don't remember, to be honest, I don't really remember the bunch of reasons, but I think I saw JS in LeetCode doesn't have heap data structure. Apparently it has. But for Python, it kind of makes more sense because it's in default standard library. So heap queue, heap push. As far as I remember, this is in the default standard library, so it makes it more like native and stuff. Python is still more concise and less code. Python has a lot of syntax sugar that JS doesn't have. For example, if you have map, and then you are, by the way, why don't we have my keyboard showing up? Give me 1 second. Exactly. So in Python we have something like that. If you want to count frequency of numbers, you can do just this. And you'll get map instead of doing for loop, counting them, and you got the point, right? What else Python has? I think there are a bunch of more like teeny adjustments or teeny things that Python is a bit shorter than JS, and I just decided, no, I will use Python for that. Also, Python is much more well known for interviews, so if you get interviewer, he will probably know, or she will probably know the Python, so it will be easier for you to pass the interview, because it can even, he or she can even help you with some syntax or API, whatever. Back to the problem. So I'm considering keeping track of the following things. We should keep track of current time, which is initially 0. Let's say we're gonna have entering people and exiting people. These should be dequeues or queues in regular computer science understanding. Now, what else? What else we have here? We have arrivals. Are arrivals sorted? This is first question. Do we have any mention here? We don't, but we can sort it on our own. So let's assume they are sorted. So if they are sorted, we kind of know that time monotonically increases, so this is good. Then we have either entering or. So what about us, since this is sorted? We can maintain this index and sort of while current value that we just got from this array is still equal to value we are iterating in. So let's say we are at 1, current value is 1, we move forward, current value is equal to, indexed value is equal to what we just got previously. So iterating up until we get to up until 2, we are kind of iterating, we're gathering the people and their state, meaning whether they want to enter or exit. And then we can just formally implement these rules, no? Which means, yes, and we updating second to the currently popped value. So what do I mean by that? That we are going to iterate, this is still code. So we're going to iterate, maybe even with while loop. Yeah, I think we need a while loop. I feel better with while loop. So we're gonna iterate, we're gonna have index, which is index of this person or other person, whatever, and we're gonna iterate over while loop, less than len, whatever. And here we're gonna update t to whatever we have in this array. So arrival person. Arrival is time, right? Yes. So arrival, this is our second, and while it's the same second, we kind of keep going. So initially we can put second as, I don't know, arrival first, and then while this second is still the same, that current index, and still less than length, we kind of keep popping the people, and then we sort them and put them to the right queues. So depending on the state, we're going to end up in entering or exiting. Then in the same loop here, in the same iteration, we are going to decide, so we would need to create a result the same size of arrival, because index equal to people or person. And then we're gonna kind of based on these rules. So yeah, now how do we organize these states? So state, we can have a door state maybe. Can we have a door state? Maybe we can have door state, which is can be let's say 0, no action happened, 1 entered, 2 exited. Let's say these states. And now if no action, we just, who's going to go first? If there is, the first one is going to be exiting, right? In case of, yeah, so we should also check 2 cases. So one competitive, when you have multiple people wanting to use the door, and non-competitive. For non-competitive, we just pull the person and set the time that is equal to t and move on. When it is competitive, the interesting case, we're going first to pop from the people who are using, yeah, so we check the state. If state is no action, we pop first that should be exiting. If state is just entered, we pop whoever was entering. If state is exited, we pop again exited, right? Kind of makes sense. And once we pop the person, we kind of put it to our response. To me, it makes sense. Let's try to implement this. Yeah. So let's try. We have entering each stack queue. Probably let's do it from collections import stack queue, and we have heap queue here, right? Do we? We don't. Maybe it's not in std. Maybe I lied to you. I don't know. So whatever. Exiting. So stack queue. Now we have door state, which is 0 initially, no action was done. After each action, we should kind of, what to say, revise it. I'm not so sure about this ordering. Because we have another rule, among people going in the same direction, person with the smallest index goes first. If this is ordered by default, we don't have to do anything extra. If this is not ordered by default, we need to sort it. In this case, we have a problem, because how do we decide which person should go first if we have like 3 persons wanted to enter right at the same second? We need this index. Oh my God, I don't know then. Let's assume just that it is ordered. Does it make sense that the time is monotonically increasing? Hopefully. And then we're gonna see. So I will just assume it is sorted, but you should clarify it on the interview. If at some point we will understand in intuition below that it's not, then I will revise my solution. So for now, we are defining our t equals to 0 initially. And we are doing while, and yeah, let's do and we need also index or person. So while person is less than length of arrival, let's also define the result. Yeah, less than arrival. Here let's do save, and let's do again one more. While person is less than arrival, and arrival person Can you see it yet? Yes, yes, you can. Good. And arrival person is equal to current t, which should be 0. Well, t should be not this one. T should be arrival first. Yes, yes. So while that is true, we kinda, yes, in the end person is equals 1. And while that is true, we keep appending values to our people that are kinda stuck in the queue. Hello, hello, got new people. So entering, if, exactly, if state person equals 1, it means it enters, right? No, it exits. Yes, exits. So exiting, append. And what we need to append here, probably person. Else entering, append, person. Cool. And then we increment up until we have the same value. Once we don't have same value, yeah, we end up. And now we should define competitive, whether it's competitive case or no. Competitive. So competitive case, is it competitive case if we have all of them entering, for example, and no one of them exiting from the door? I think it's kind of competitive, but it's trivial for us. It should be trivial for us. Yeah, but still, okay. So competitive will be defined true if length of entering plus length of exiting more than 1. Or we can just do this. Wow, what the hell I was doing? Okay, and then if not competitive, it's simple. We just pop the person and push it to the response, right? And make it arrive or use the door at the time t. So while or otherwise if entering, then we are doing p entering pop left, and we're doing result p equals t. Okay, we can do it a bit better. Yes, and then we just put it and we just continue. Now non-competitive, competitive case, which is the most interesting one. By the way, yeah. Actually, we do need this. We do need this. Because we need to remember the door state. Or don't we? No, the door state should be no action, actually. I guess. No action is 0. Now, non-competitive case, which we need to use these rules. So the rules are saying if the door was not used in previous second, people who want to, so exit is performed the first. So if door state, if door state is equal to 0, what we are doing, yeah, we are starting first exiting. So if exiting exists, we are doing the following. We popping it. Once we pop it, we kinda we need to do it, yeah, we need to do it every single. Oh no, sorry. Oh my god, it's actually much more complicated than I thought. Because as we go, meanwhile we are sorting out these things with competitive and non-competitive. Every single time we're spending 1 second, and meanwhile we might get new person coming in. Do we have any constraints about that? How many seconds we might have? Because if we get 0 and second element can be 1000, yeah, we cannot sustainably have a good algo on that. So we need to add people as we go. Wait, but maybe this actually would hold it? Wait a moment. So at this point, when we got 2 people in the first second, while they were figuring out, the second person actually entered. Person 3 enters at time 2. Yes, so we have this case. And for that case, let me try to finish. So we actually should just increment t in the end. And that's it. And that's it. Wait a moment. No, that's not it. The time handling here is hard in some sense, because we don't want to just have timer in while loop incrementing every single time by 1. I mean, we want that when we have competitive case, but we cannot just have competitive case here, like while we have exiting or entering, and we just while looping while we figure out this. No, I don't think this can be the case. Yes, it cannot be. It cannot be, because we should dynamically react to whoever comes to us. So when we kind of in competitive state, we want to move 1 step ahead, and then maybe we want to get more people depending on our time. How do we know that we need to take more people depending on our time? We need to figure this out. I need to go back to this case. Oh my god. It's hard problem. It's hard problem actually. It's pretty hard problem. To me at least. Hello brother, Love from India. I'm diving myself into cloud and DevOps, so could you please guide me as I'm still pursuing my college? Cloud and DevOps is not the easiest start, I would say. You need to know a lot of stuff to be DevOps and a lot of experience. So I'm not sure about that. But try to get hands-on experience, try to get internship. Learn Kubernetes, Docker, networks, internals, kernel. This is what you would need. and distributed systems, of course. The practices for deploying, rolling out, like safe deployment practices, SLI, SLA, SLO, kind of try to become SRE in some sense. Yeah, there is Google book called SRE, you can read. Imho Python is just human readable and it makes sense even if you try to code in heuristic programming language. Wonder myself, you'll write something that looks like Python. Yeah, can be, yes. So what do we do with time? So initially time is equal 0, or the first element, which is 0 anyway. Now we have processed the person here in non-competitive, and time should increase by 1. Kinda makes sense. Kinda makes sense. But we might have the case like this. What do we do about this? So when time is equal 0, time will become 1. And somehow from 1 we should shift to next time slot. So and person index is still this one. So person index is still this one. No, person index actually stepped according to this logic, because while person is rel, less, blah, 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 while person t, we would check this is 0 still, append it, and this here person would be not equal to t, so we're gonna break. So person is on number 2. We have solved it, and t moved ahead. But now this would list what? Arrival person, which is 2, is not equal to t. We don't have competitive, and it will kind of break everything. I don't know how to handle t, how to handle time in this case. So we kind of want, let's try to do it case by case. Thank you, brother. Can I connect you on Instagram? Yeah, you can. I don't have any other to guide me as I'm alone in my family and I'm into IT field, but I have a determination. Good for you, yeah, go for it. Will you be my sensei, please, to use here? No, I'm not sensei. I'm not that good to be sensei. Okay, let's try to figure out. So when t is less than current person, we kind of want to shift t to current value, right? Yes. Then we might have t that moved a bit ahead. Can we have this? Or we actually cannot. If we're doing it this one step by step, so let's say we can, depending on the state, we popped from exiting or entering, did our stuff, since it was one move, t plus 1, and then yeah, it's kind of not possible to me, no? It seems like, because what will happen, let's say we have these two guys, we popped 1, so t was what? Let's say we shifted 0, and then we somehow shifted it to t equals 1, whatever, and then we kind of moved, progressed, and now person is this guy, which is the next guy to process, and t equals 1. So we will increase t to 2, and this is exactly when t is going to be less than arrival person. Mm-hmm. Huh. Oh, Nicholas here, amazing. Tell us how your Amazon round went. I was a Sigma on bar razor. Good, good. We are trying to solve your problem, essentially. But I'm stuck, I'll be honest. I'm stuck with how to handle the time in this case. Because we don't want to have time in the while loop as a... So we don't want to wrap everything in while loop and just increase time every single cycle in a sense, because probably we might have case like that, and that would lead us, for two values, it will give us 1000 cycles for no reason, right? So we don't want this. We want somehow wisely shift the index, right? We want somehow to shift the index. And how can we do that? Let's try again this example. So t equals 2, 1, 1, 2, 4. We parse this guy, and then we want to increase t by 1, and it somehow appeared to be exactly the same. So p equals t. Then we start processing p, and we moved p to this guy. T is still 1. We want to emulate this competitive door lease and release. And I got low-level design in the first round, and the requirements were so ambiguous, so I couldn't focus on creating the proper algo and explain on the words how to solve it with 3 different approaches. Hope I get that lean higher. Okay. Must dominate LeetCode and Genai tomorrow though. Okay, cool. Cool, good for you. Yeah, can be done. I also got pretty ambiguous requirements in my coding interviews for Amazon, so yeah. How many behavioral questions have you been asked today? For 2 rounds. Or was it only a single round today? I don't know. Okay, so if t is less than... Oh, okay, maybe we can do the following. So if t is less than p, you kind of do nothing, right? So here, if t is less than a rival person, which is this case, we don't do anything. Because we for sure know we have somebody exiting or entering. So if t is the same, we'll keep adding. Right, so this is kind of... Can t be more than... So yes, again. So if t equals to whoever right now is a rival, we just do this loop and we adding everything that is in current second. If t is less than ARP, can it be? Yes, it can. Then we just don't do anything. So we just skip this. And third case, if t is equal or more than p, there is a company who wants to recruit as Java developer. They are conducting exam and asking all students to install VS Code or Eclipse if they want to take tests. Maybe Metal other platform use. I didn't get the last sentence, but it's interesting. I mean, okay. I mean, in my first company, you were required to have your personal laptop from which you are going to work. You're going to work, essentially. But yeah, if you don't have a personal laptop, you're not allowed and you're not hired, you're fired. Like 3 or 4, but my answers were so detailed, it took 5 to 10 minutes to explain, and the interviewer was basically scribing everything. I kept him occupied. Good. I ran 30 different questions with ChatGPT yesterday. Amazing, good job. 200 students are there. What task they are going to give us? I don't know. Yeah, well, yeah. I don't know. Okay, so T more than or equal to P. Is it possible? I don't think it's possible. Let's take this case. Right, we have P equals here. Then for this case, what I wanted to do, this is interesting one. So look, here we at arrival, which is equals to whatever. So this is kind of okay. Let me put this. L if t equals to arrival person, then we are doing the following. This is an interesting case. So let's say first we went and we got to this else if. So we are moving it up until we are equal, so person will become this number. Then we are going to conclude this is not competitive. We're going to do this, increase t by 1, add the person as a response. That's it. And now our t is going to be what? 1. And we ended up in this case. But we don't have any more people, so it's not competitive. So we skip this round only if, or rather no. So we can do the following. So if t less than arrival and length entering equals to length exiting equals 0, then we are doing essentially the following. We are reassigning arrival person. And we just continue. Yes, damage amazing. Yes, this way we're gonna skip it. And if it's less than, but we still have entering or exiting, we are going to conclude whether it's competitive or no, and then just, yeah, essentially we're gonna proceed with competitive processing. Now I'm good with that. Now I'm actually good with that. And what we have to do in this case also is to make sure that we don't while looping here. So again, this is competitive case. I would even put else here for us to not be confused, and then we can do this. Okay, so many comments. How many people are watching us? 10 people, okay. Surprisingly, a lot of them. What motivated you to get the hard work and finally got placed at Microsoft? What was the edge? Sensei. Oh man, come on, I'm not sensei. What motivated me? Right now, LeetCode motivation for me is anxious about being laid off. So if I get laid off by some reason, I don't want to have a 3 months preparation pause, because I might need actually, I might have some boundaries on how many time I have to find another job in this country. So anxious. Before that, to Microsoft, just wanted to get to big tech. I realized from guys who passed the interview and got the offer that LeetCode is the way. I started doing LeetCode because I realized this is the skill I need to get to FANG. That's it. To be this top, I don't know, 70 percentile, 80 percentile of all engineers in the world. Or I don't know, maybe it's even less. I think we have a lot of people in FANG, so maybe it's even majority of engineers, so maybe it's like median of engineers, but yeah, that was my motivation. Do you still write code by hand at Snowflake? No, we don't do this. Here in Ukraine, outsourcing everyone went full AI mode. Yeah, we do as well. Even EPAM, soft service, rolling it out everywhere. Yeah. Everyone got crazy about that. And I actually have, if you followed my Telegram, and I guess you did, I already kind of gave an example of AI first project that got delayed by 3 months because no one actually, for 3 months we are resolving bugs that there wouldn't be such bugs if we do it old way, you know. So I only write code myself for LeetCode or side projects now. The same, even for side projects, I don't use manual programming anymore. Side projects just write code straight away. They're simple. AI models are very good with simple and small projects. Only LeetCode I'm doing by hand. Any day now they'll just tell PMs to wipe code, the POC themselves will also how it's going at your side. Yeah, the same, we have the same. I'm back, how do you do work with AI now? Well, as everyone else, you open Cursor, Claude or whatever, you tell AI what to do. It does the thing, then you review and make sure it's tested somehow, and then you deploy. Yeah, that's it. Nothing fancy. Okay, I'm sorry. Let's get back to this. So if the door say we come back to this 4 criteria which we should decide what people are allowed to go first. So once door state is 0, we should first pop exiting person because this is the first one that should go. And if we popped this guy, we put it as a time. Then we put door state as exiting. Which one is that, by the way? Exiting is 2. So we put 2 here. And now, essentially, that's it. If we don't have anyone exiting and we have entering, in this case, well, we do exactly the same, but we put door state. The code will be cumbersome, but let's make sure it works at least. So we do the same with entering, but door state is going to be 1. Now, else if our door state is going to be which one? Yes, all good. If the door state is 1, which means we just had entered, what we should do, we should just pop from entered folks, and that will be it. Or no, oh my god, no. I think I was wrong. We would have so much more complicated code if we do this criteria for competitive. I think we should do the following. If this is more than 0 and this is more than 0, then it's competitive. Otherwise, this is not competitive. Yeah, and then we can just do the following thing, right? Yes. So for competitive, we should have both entering and exiting people wanted to go out, right? Right. And then we can essentially remove this guy. And then we can, if door state is exiting, right? Was next entering. Okay, this is entered. So if we just enter it, we should do the following. Wait. This is so ambiguous, by the way. In this example, person 0 wants to enter, it enters. Okay, wants to exit. Person 2 wants to enter. Since someone entered at T1, but fuck, man, no. Why you are confusing me? No, it shouldn't be like that. No, because this is so confusing criteria in this case. Because since someone entered at T0, but T0 we didn't have competition for the door, so it was single person. We should forget about that, no? Or we kind of keep it as a continuity. Anyway, when I was solving this problem, I don't even remember how I was thinking. The guy just gave me 25 minutes and wished good luck. I remember that I filled the question and then drained them. No, 25 minutes for that question is too small. I think this is crazy interviewer, in my opinion. I'm not able to solve it in 25 minutes. I'm not able to solve it in a 1 hour, whatever, however we are streaming. I don't know. How much time we are streaming already? I don't know. So, yeah, this actually changes everything. But what about the case that we got guy, so let's say person 1 entered and second 1, then there is second 2, and we have the guy who wants to exit. Like, okay. In this case, we should allow him to exit because it's not competitive. Even if we have 2 people wanting to exit, we should start exiting. Okay, so it's not that bad. It's not that bad. It's not that bad as I thought. There are so many edge cases, come on, and the single example is not enough to understand this problem properly. So essentially, for non-competitive case, unfortunately, we will still have to do this. So we have entering, then we do entering. Yeah, essentially, we can do this. Entering pop equals T. Then door state. Entering is 1, I guess, right? We should put it lower. Yeah, entering 1, else the same thing. But exiting. Cool. Now it feels like it's better. Okay. If door state is 1, so previous door state is 1, which was entering, we need to drain first. We need to drain first entering as well, right? So yes. So we shouldn't even doing that if, because we know competitive is only when we have both. So for that, entering pop left, result P equals T, door state equals what? Equals still 1, or doesn't change, or whatever. Also, I forgot that in this case, I should put door state equals 0. Reassign it. Okay, and then we have the last case, else if door state equals 1, which is 2, which is exiting, right? Yeah. In this case, we drain only exiting. So kind of we can do this. Amazing. Now, let's try to run it, at least in our example, because this got really crazy. I would say this is pretty complicated problem, at least for me. Sorry folks, but I'm not that clever, I'm not smart guy, never was, never presented myself as, so I'm struggling with this problem a bit. This is arrival, this is state, whatever, and we're gonna have our result. Can you see it? Yes, you can. Result 1, 0, 0, 0, 0. 5 elements. 0. One more 0. Let's put indices under them so it's much more convenient. Yeah, like this. Come on. Cool. Now let's try our debugging. Our nice, amazing debugging. To update in the end, yes, we do. So, again, this is coming from assumption this is monotonically increasing. So we have t equals 0 because arrival is 0 first. Okay. So we go what exactly? We go. We can actually move this here. We go person less than arrival. Yes. T less than arrival person. And let me also put the person here, which is 0, right? Yes. So this is not true, this is true, and while person is less than arrival person equals t, which it is state person 1. In this case, it's not. We're adding entering. Entering, adding person 0. Then we increase person. Then we increase person, and person moves to this place. Amazing. Now, competitive or no, we have only one entering, so it will not be competitive because this guy is false. Not competitive if entering, then we just pop. So we pop to the 0 guy. I put door state to 1. Where is my door state? Door state to 1. It was 0, by the way. And then we adding 0 equals t, which is 0. So we put result as 0. Kind of overridden it. Okay, anyway. After that, else is skipped. T plus equal 1. Amazing. We keep moving. Again, t equals arrival person. This is true. Person is state 1. Yes. So we are adding it to exiting. Exiting, we are putting person 1, right? Yes. And we move on with another person, still less, person equals t. yes, it does. So we're still adding it, but now it's to entering. Okay, so person 2, amazing. And then we move person again, and it's not equal anymore. So we end up moving out from this loop. Competitive, yes, it is competitive. We have both. So we go here. Door state previously was 1. You remember that? So for this, oh my god, I need it a bit more. Yes, amazing. So for door state 1, we popping from exiting. So we're popping 1, and we pushing for this guy. What we pushing? T. Put door state 2. Door state 2. And here we pushing T. T equals to 1. I'm sorry. Because wait a moment. It shouldn't be like that. So exiting, oh my god, my debugging skills. So exiting, we have 1 in exiting. Again, let's move it again. So not competitive, door state 0 or 1. So door state should be 2. Oh my god, stupid. Oh my, I'm stupid. So door state is 1, then we should pop from entering. Good. We pop from entering, which is 2 essentially, and we're gonna do for index 2, put time 1. Yes, so far it works. Then we end up setting door state to 1 still and increasing T. Amazing. Now what we do? Now it's simple case, but let's try to see whether this stays. So 2 is less than arrival person, which is 2. And it's not less, you see. It's not less. So we are dropping to this guy. And while these are equal, we add in state person for person 3. Person 3 is 0. So for 0, we kind of appending it to entering. So we append 2. Amazing. And then we move person even further. Now it's not equal. We continue. Cool. Well, not continue, we go here. We can see that this is competitive. Door state is 1. So we just enter it. So it's 1. We again popping entering. Amazing. This is second. Sorry, we should add the person here, right? So it wasn't 2, it was 3. I'm sorry. Yes. Debugging skills are problematic. Then we're popping 3, and for 3 we set time 2. So far it works. And we increase time by 1 after that. For me, I have some confidence that it will work now. So now time 3, this is still less than 4, so we proceed. Now it's non-competitive. The door state is 1 still, but do we care about that? Probably no. So we don't have entering, we have exiting. We put door state 2. We drain exiting once. Exiting is going to be 1. We should put it value 3. Exactly. And then what happens? We can increase time. It's time to 4. At 4, we are popping the last person, which has state 1, which is exiting. So it's going to be person 4. Again, non-competitive, exiting will be popped. So you put this as a 4. Then it's t plus equals 1. We're going to have 5. But person is over. So we return result. To me, it seems like it will work, honestly. Let me try to do that. Create a free account. Okay, I'm sorry. I will do it on separate screen to not expose expose any additional information. Okay, I'm here. Cool. Now run tests. Yeah, we have some test cases not passing. Let's check them. God, what am I? Emails I'm getting. Okay. Okay. So we have a test 4 not working. Sorry, yeah, let me check then. Nicholas, how do you feel about this solution? Because you have solved it actually, and you got the positive feedback after that, right? As far as I remember. What's the name of this beautiful background music? It's music from Reason, the game called. Yeah. The game I played when I was child. Amazing. It's so cool to work with that music. Sorry, I'm going to get to the chat. What's the time there's here? It's 3 a.m. in India. It's now 10:43 p.m. What's the time there's here? Okay, you just okay, whatever. Let's try to debug what just happened with these test cases. Oh my god. So what is this input? 0, 0. So I would say arrival is 0, 0, right? And this is 0, 1, which is exactly our case. Okay, door state is this one, this is this one. So how would we proceed? We would put t as arrival 0, so it will be equal for sure. So you got 2 people at the same second, and the output should be that first one is again. I think this is this fucking confusing problem. Person can be finished, but queues can still be full. Oh yeah, right man. Yeah, good catch. Good catch. It's amazing catch. It's nice catch, but I don't think this is the problem with this test case. This test case has different problem. Or entering or exiting. This is good. This is a good suggestion. Yeah, and in this case, yeah, I should drain them full. Yeah, you're right. Good catch. That's a nice catch, Nicholas. You got a right positive feedback, man. I mean, you're performing better than me. I would fail this actually, because I would be already out of time. So now the state is, I think what we need in non-competitive, that first we need to drain, or no, in this case it will be, we would have competitive case, right? Yes. And then we should first take person that was 1. This is how it would look like. Person 1. Yeah, I would ask for hint many times already. Yeah, but I'm wondering why this case doesn't work. So I'll put this case. It will be 0. It will be competitive. Door state is 0. So exiting should be popped first. In my opinion, it should work. No. Wait, I don't understand. Like, okay, let's try to run one more time. Yeah, still doesn't help much. Of course. Of course, but where is this small example? Let's try to debug this case. Just like 1000. This is the time of arrival, right? And my output is 0, 0 somehow. So how we would perform? We would put t equals to 0. Yeah, this is true. Person less. Yes. And t less than arrival? No. We would go this way. And then again, while person equals t, yes, that would be true. We would add one is exiting, 0 is entering. So you put 0 to entering. Cool. And then we would increment, and this will not be true anymore. So we would push person to first index. Okay, it's non-competitive. If we do have entering, we just put 0 and put it 0, which doesn't do anything. Doors stay, we put as 0. Next step, we see that person less than arrival, yes, and t is much less than this value. So yes, and entering equals length of exiting equals 0, which makes sense because here we would pop it, right? Oh, pop left first of all. It should be, but this wouldn't change anything in this case. We anyway pop it. So t equals arrival person. So t would be equal to this guy. Oh my god, yes, we can have it less than, or sorry, more than. Less than arrival person. Okay, anyway, let's do this and try to debug it later. So person we would move here, door state would put back to 0. And we haven't added after this. Yes, we should have added the person again. Yes, because we switched to this guy now. And we just skipped it, right? Or other way we can do that, we can just do this. Now it should be better, but now we can actually have time which is more than person. So we can have t more than arrival p. What do we do about this? Too much time spent in it, so I will be just speeding up a bit because I still have work to do today. Yeah, past. Come to Papa. We did it. We did it. So, Nicholas, was it anyhow close to what you did? Tell us. So I will be, this is the kind of the solution. I would maybe even add it somewhere. I don't even know where. Where can I add it? Okay, I will add it to Telegram. Yeah, for those who are on the stream. How do I add the code piece? So you can play with it later. I hope it will work. Yes, it will. Okay, now let's drop this guy and let's move back to normal view. Okay, so check in the chat. And also let's for fun just realize how much time it took me to solve this problem and actually ended up being in edge cases that I didn't anticipate. Yeah, it will be fun. It would be fun to see. Where is my content? My God, why is so slow? Ended up being in edge cases that I didn't anticipate. Shut up. It's 1.5 hours. Okay, let's cut 15 minutes of talking. It's 1 hour and 15 minutes. And I will remind you, folks, that our legend Nicholas, who is in the chat right now, he solved it in 25 minutes and got positive feedback. And Nicholas, a guy who got that question on the interview, yes. And he's new grad. Okay, Nazar, I'm off to sleep. I'll be cooked after that problem. So the question, if you're a machine, then who is Nicholas? Yeah, he's double machine. I don't know. He's monster. Yeah, can be he's monster. What is your age, dude? Sorry for this question, but I'm getting to know that how inferior I am. Probably it was question to Nicholas, yes. I just majored in math, so LeetCode is easy to me compared to the proof courses I took. Well, yeah, but I don't know shit about system design, which is much more important. Well, up until senior, it's not much more important. Let's go, bro. Yeah, let's go. Good night, sensei. See you tomorrow. Yeah, see you, man. Damn respect. I mean, it's not respect, to be honest, to this problem. It's not respect. If I solved it in 25 minutes like that, this would be respect, I agree. But this is fucking embarrassment, I would say, not respect. After 800 problems in LeetCode. Yeah, I solved it just like this, but I didn't cover every single edge case possible. I didn't dry run, but I make sure I explain all the edge cases on words. Nicholas, how was your interview? Yeah, so Nicholas, your machine, because for me it was kind of hard question. It was hard question, and a lot of edge cases that I just noticed on my way. I didn't do it the proper interview style that I explain everything and have mental model and plan for the code. No, I was doing it as I go, so it will be no higher decision for me, definitely. Let's check the intuition. Okay, the queue, two queues, blah, 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 QA current time, index pointer, doorstep. Okay, anyway, you can read it later. I will just paste the link here as well. So yeah, amazing. Now we are moving to our default LeetCode. So I got the premium screens from my friend, and we're gonna solve some problems for some company that I'm interested in, potentially, because, well, we are going to kind of check real time how far we can get with that, and to show the people on the stream how the preparation is going to be. So to sum LeetCode. We actually solved it last time, but we can do it again. You remember how to, I just remember how to do it. Actually, yeah, you can be surprised this is asked in some of the companies. Yes, it's asked because this problem has like 6 follow-ups different that you might end up having. But you didn't have an interviewer. The thing is that in the company I interviewed, they put a lot of emphasis on collaboration. So I communicated everything I was thinking, and he was saying right or wrong without me having to write the code. Okay, makes sense. Yeah, maybe I don't think I would do it in 25 minutes. So good job, man. You are actually a monster. Yeah, that's a great job. Okay, so we're gonna have map. Yes. Yeah. So for to sum, you remember there is formula, which is num1 plus num2 equals target. And now if you want to find num2, it's target minus num1. Essentially, this is the thing you should find. And now you go like this. First you check if needed is target minus num, or we can name it as num2. And now if num2 in map, return map num2. Otherwise, we just do map num equals index. No, we should return this one. So map I and map num2. Just a default case. Let's check it very quickly. So we have this and map. So initially num is going to be 7. 7 is not in our map, so we just add 2 to 0. Then second one 7. 7 is going to be 9 minus 7, 2. 2 is in the map, so we return what? 1 and 0. Yeah, kinda should work. I got a little lost in low-level design, but I was total sigma in bar riser. What is bar riser? Dominated that manager with details. I have Gen AI around plus coding LeetCode tomorrow. Need to get at least one strong hire. Yeah, I think you'll get it, man. Come on, you're strong if you are able to solve it in 25 minutes. I mean, I got bug at production currently during the deploy. DevOps disappeared. I don't know what to do. Oh my god, man! You see, I have opened Snowflake laptop for a reason. Because right now I'm debugging one issue and US folks woke up and we need to debug it before tomorrow. So after the stream I will be debugging till I will debug it to the end and fix it potentially. Crazy stressful work I have. Next one, add two numbers. This we already solved. Is it linked lists? We just solved it. I don't want to repeat it. Yeah, we solved it last time. Sorry. Median of two sorted arrays. This is hard. We wouldn't go with that. Longest common well, we kind of can go median of two sorted arrays. Let's try it. Okay, let's try to solve it. Given two sorted arrays nums 1 and nums 2 of size m and n respectively, return the median of the two sorted arrays. The overall runtime complexity should be O log m plus n. Sounds like heap to me. Doesn't it? So maybe not heap. So two sorted arrays, are they the same size? No, they're not. So we kind of know, we know, no, it should be log n, logarithmic. Okay, that's hard. Median of two sorted arrays, bro. Oh my god, I hated this task. Even though I love heap problems, this one is the most soul-sucking one to develop intuition. Oh fuck. My knee. Also, what saves me is that I really work a lot on my communication, so even when I don't get enough time to solve, I'm trying to annotate and explain every single line. Yeah, it makes sense. It makes sense. Yeah, man, this can save you for sure. It can turn no higher to lean higher or even to just higher. Let's be honest. Yeah, that's true. So let's try this one as a last one, and I need to go to solve it. Help Snowflake stocks grow. I'm joking. I'm joking. No financial advice, nothing like that. Just joking around. So how do we build intuition about that? And we need to log logarithmic time. Okay, the arrays are sorted, which already kind of helps us because we can go from two directions, right? We can go from two directions easily. But to get median, we should kind of process all of them, right? Or no? So let me try to draw. I don't remember. I last time solved this question exactly a year ago, so I don't remember anything. So you have two. Can I? So you have two arrays. They can be something like that. And then kinda like cards, they would be inside each other in some point, and we need to find the median. Ha. Okay. That's an interesting one. If we just go through this array, it is not O(n). We need to do O log m plus n, which is, I don't even know, maybe it's somehow using binary search, or maybe no. I kinda run out of idea. I might need a hint here because I don't know. Unfortunately, no hints for us. To be honest, I don't know how to do it because we cannot touch all the elements in these two arrays. We cannot touch it. We just cannot touch it. Because if we touch all of the elements in this array, it means, you know, it's not O of, it will be O n plus m. So this is not affordable. How to do it with logarithm? We should somehow pick up the elements. I don't even know. Can we maybe somehow start from the middle of both of them? No, I don't know. Oh, someone is living in Prague. Nice. I've been living in Prague for 4 years. That was nice. That was nice experience. Anyway, folks, I don't have any idea about. So at this point, if I'm in the interview, I would say the following. So I know how to do it in O(n). So essentially, with sort of probably 2 pointers, somehow you can come up with it. Or with even 1 pointer. Yes, with 1 pointer you can kinda, no, with 2 pointers. With 2 pointers and 1 counter you can do this in n plus m. But about logarithmic, maybe some binary search can be used here. Maybe no. Oh, it's actually binary search. So let's say I got the hint from the interviewer, it's binary search. So how do we do that? How do we do the binary search? Spoiler, you need more than 1 heap. Yeah, I knew that, but I still kind of cannot come up with. And it doesn't have heap even as a topic. Can we do it with heap at all? I'm wondering. I just don't see how we might omit touching some elements. Then we probably need to use binary search, which will make it log of n. All right. So even if with binary search, how can we understand this is median or no? Sorted always binary. Yeah, seems like. Also with median of 2 arrays, but not sorted. Yeah, binary, yes. I don't see how heap can be used here, but maybe binary search can be used here, which I don't really like binary search at all, ever. So yeah, probably let's leave this problem for next time. I really need to go. I would solve it, but I really need to go and still work for next 3-4 hours and still kind of try to get some sleep, which is, I don't know, because tomorrow I have training and stuff. So anyway, let's try to solve longest common prefix, which is this one, and then LeetCode. Amazing. So write a function to find the longest common prefix string amongst an array of strings. If there is no common prefix, return an empty string. Longest common prefix sounds like try. Why is it then easy problem? Just want to double check. Yes, it's try, of course, but why it's easy? I would say implementing try is kind of mid problem. But let's do a try. Let's do try. How do we implement try here? So we would add characters, and every single time we can also add the number of times we visited while we were adding the character. Okay. So this would be for sure try, but which try? So we can add it to try, and the longest common prefix should be the one while we have the single node. So imagine we start our try, which is, let me even draw it right. So try, what is try? Try is essentially a tree with multiple childs usually. So whenever we have multiple childs on the root, we for sure know that there is no common prefix, because it means we have 3 common prefixes, like this case, which one will be dog, another one will be race car, and another one will be car. So this is not the case we want to go with. In case of flower, we're going to start with this guy, and the only single character we go is flower, F. Then we can go with L. And then we have O and I. So at this point we will have O, and at this point we will have I. So I think the longest prefix is the one, like we should just start with the try, built up already, and move from the root up until we meet branching. Once we meet branching, this is the terminating longest prefix. Hope it makes sense. And yeah, to build up the try, once I got the problem for try problem in one of my interviews. Okay, somebody has commented something. Okay, later on. So, how do we build tries? So I usually do it with OP because like this is much more natural way of thinking for me. So try has for sure children. Should be self children, which is going to be just, it should be array. $26 initialized by none. Can we even do that? Yes, we can. Because initially we don't have any children, but why we want statically lengthed array or sized array? Because once we have it's lowercase English letters, so we only have 26, that's why 26. Once we have letter B, we can find and convert it to index and know whether under B there is something or no. So we cannot do it sequentially adding up to the element. Now we also want current character in a sense, but do we actually want, yeah, it can be additional data structure here. Let's add it just for sake of adding it. And then it will be it. We don't even need to know whether it's terminating word or no. We would just go as deep as possible. What we also can do, we can kinda, as we go, we can add num of nodes, or I don't know, size. And now, how do we process it? For each word in strings, for each character in word, there should be root, or rather, let's name it node, because it's not kind of tree, it's just one node in this tree. And initially it will have character, I don't know, -1, no character, because root does not represent anything. Now we would go the following. We would go node equals root. And then if character not in node children, or rather, since it's not map, we actually could do it as a map as well. Why not do it as a map? Can we do it as a map? I think we can. Oh, sorry, I have WhatsApp. I think we can do it as a map. Yes, and then we don't need size. Sorry. So if character in not children, not in not children, then not children char, we're adding new node with character, and that's it, an empty children, whatever. And now we're moving node equals node children child. This is sort of how we build up the tree, I guess. So always start with root. For every character, if it's not in the children, we can build a new one. If it was in children, we just move on. Amazing. Sounds good so far. And then prefix, let's keep it as array. Let's put node as a root. And while node children length equals 1, we're kind of doing the following. Node children. The only one that we have, how we can get this? Can we know how we can get just single element in the map without iterating over it? That's a good question. I don't know. You know what we can do? This will be a bit of a hack. Probably this is not the right way of doing that. But if we have a single child, it means this character should be present in all the words. So what we can do is the following. First word string 0, index equals 0, and we can then do the following. First word index, and then index plus equals 1, and this is how we go. And also, yep, and also we should add prefix at this point. Prefix append something like that. So let me draw what we have just done. So initially we would have root, we would have, let's say we are parsing first word flower. We would have F, then we would have L, then we would have O, then, or rather, yeah, I already know that this will be the case, which is O, and then W, and then E, and then R. And then this should be empty completely. Then F, L, O, W, and that's it. Sorry, then we should mark the word, because I'm thinking about this example then. The longest common prefix should be flow, right? But it will not be flow. Sorry, it will be flow, it shouldn't be flower. Yes, so we need to mark it. Oh my god, so self. Yep, so we added the word equals to true here. And now what we're doing, can we just do the same with the first? Let me check one thing. So let's say there is map. What if I do map items? I cannot access it by index. How to get the first one from the map? I don't know. I see. So how we will be doing? We will be doing that with first word. Okay, and then for character in first word, it will be capped to this. Because there is, I don't see any other way how we can kind of see and follow the only single child path. So for that, again, if not, first of all, if not children, if length is more than 1, we kinda break, yes. Otherwise, not children character. Or not children or if it's word, then in this case we kind of don't want to proceed. Or no, sorry, not that fast. So now we are adding prefix append not character, and if not word, break. When did I solve it last time? Okay, a year ago exactly. So now it should be return join prefix. Whatever, let's try. Let me draw again our flower. So it'll be flower. So this would be the word, and this would be the word. Then we have FLIJHT. And now let's say we take the first word, which is flower. First we got f is not more than 1, so we proceed. Not equals children, so not becomes this one. F, we are adding f, amazing, so f is going to be added. And it's not word, so we're moving again. We again have single children, so we're moving to L. We see we're adding L. It's not word, so oh wait, sorry. Yeah, I think we should actually add this check here. So initially we kind of go, what is our node? We started with index, with word, with character f. Our node is initially this one. Then we are moving it to f, this guy. Prefix append f, okay. Children is single, yes. Is it word? No. Moving here. Appending L. Children more than 1, yes. Breaking. Let's try this. Let's try this. It will be the last one for today. No, it doesn't work for this case. Why? Oh yeah, we didn't check the root. If root like this. This is another edge case. Okay, what? Yes. I don't think this is the best solution, so let's check the best solution essentially and realize how bad we are. Please load LeetCode. What happened? Yeah. Gates via sorting. Well, yeah, we could do that via sorting as well. Wait again. Just one more time. First and last. What about sizing? You get minimum. Okay. This is brilliant. Okay, this is very clever. Okay, we would know that. I want to see try solution. Will we have try solution? No, we will not have try solution. Am I the only one who solved it with try solution? It's actually nice solution. Do we have it in editorial? It is brute force, right? Binary search even. Oh my god. So this is a very good question. This is our try, right? Yeah. How did they do that? Wait a moment. Design link count. All right. Also through the map. This is yes. And now how they... So put try. Search longest prefix. Okay, whatever. And we go through all the... What is the queue? What is the queue? What is going on here? This is wrong. This is... What is the queue? We don't have query. Like editorial, are you okay? Are you good? Like the signature of the method doesn't... It doesn't kinda... It does not match, folks. Hey. When it happened. Yeah, it's strings. It's like you have no right signature of the method. Oh my god, stupid. Oh my god, LeetCode. Why would you pay premium for that? Come on, I would downvote. Try solution has additional argument queue that does not exist in the method signature. Okay. Sure, you can do this with single loop. Yes, but you want to practice the pattern usually. Okay, I didn't know you can solve it with try. No, try is actually the natural, intuitive way of common prefix. No. I did it with double loop. Outside loop was iterating over smallest string. Okay. Alright folks, this will be it. We solved only 2 problems. Now I have to go work more. Sorry for that. So it was amazing time. Good luck, Nicholas, with tomorrow's AI coding session and additional algo round. Show them how it should be. It was me, Andrei, during all this time. Thanks so much for being with me. Don't forget to subscribe on Telegram. All the announcements and important information is going to be here. And yeah, it was nice to have you here and see you guys. Bye-bye.